Welcome to this demonstration. Today, we're going to show you a brief look at the performance of DDN Infinia in Oracle Cloud Infrastructure. Because this is a tech preview, the information presented is for potential future integrations. The overall capabilities, including the performance of this feature, can and will change. No timelines for delivery of this capability should be inferred from this demo. The Infinia architecture provides a broad set of capabilities for data management. Starting with a variety of data I/O paths that it provides across object, file, and other querying mechanisms, to the core storage components, including the scale-out KV store, always-on encryption and data reduction, native multi-tenancy, and more. And to make it capable of deployment in a wide variety of environments, we've implemented high-performance erasure coding, custom fault domains, and the ability to use both TLC and QLC flash. But what really makes it flexible is that Infinia is fully software-defined and containerized, so it can run on physical or virtualized hardware, whether it's backed by Intel, AMD, or ARM processors. Because of this, Infinia is ideal for deployment in the cloud. For this test inside of OCI, we use 6 of the BM DenseIO.E5 compute instances as the hosts for the Infinia cluster. We then use 6 BM standard E5.192 instances for the clients. The reason is that these instances have single 100 gigabit connections, and we want to ensure that networking was not a quick bottleneck. Because of this, we wound up with systems that had a lot more cores than we actually used. In the DenseIO.E5 instances, we only used 32 out of the 128 cores available for the Infinia software. We are currently investigating what other OCI instances could be qualified to help prevent over-allocation of hardware. We then ran I/O generation using Warp in distributed benchmarking mode. This ensures that each client will send operations to all the Infinia cluster nodes concurrently and create a full mesh of I/O across all clients and all Infinia cluster nodes. So now, let's take a look at the I/O in action. We'll start by having Warp do puts to populate Infinia with objects. You can see from the command that we're going to be using parallel warp across all 6 clients and all 6 Infinia nodes. As we run this test for several minutes, you see that we're able to get about 28 gigabytes, or roughly 30 gigabytes per second of put throughput. When completed, you can see that each client and each Infinia node were each able to evenly process the puts at about 4,800 megabytes, or about 5 gigabytes a second each. Now we'll run the same benchmark, but we'll do it for gets this time. We'll run the get benchmark using the same parallel warp configuration. This time, we're getting about a sustained 35 gigabytes, or 37.5 gigabytes per second of get throughput. And again, we see the load evenly distributed across all clients and Infinia nodes at around 6,100 megabytes, or 6.5 gigabytes per second of throughput. While the overall throughput was very good for a small 6-node Infinia system, we also measured the very important metric of time to first byte. We achieved a consistent 5 milliseconds time to first byte, which is excellent for S3 object I/O. As we've shown, not only can software-defined Infinia run in the cloud on Oracle Compute Infrastructure, but it can do so with excellent performance, even with a small 6-node cluster.